Hi students. So this video is on periodic trends, and we're looking at what happens to the size of an atom when it becomes an ion, and how do we explain the periodic trends that we see, specifically the ones for atomic radius. So we're going to look at some atomic radii, size of atoms, versus ionic radii, size of ions. And we're going to take a look at this first picture. Here we have a metal element. I'll let you guess what it is. Notice it has 11 protons. So if it has 11 protons, we have sodium. So here we have a sodium atom. It also has 11 electrons. That makes it a neutral atom, and it's a metal. And when metals lose their valence electrons, they become positively charged ions called cations. And it turns out cations are always smaller than the original atom. Why is this? Because there are less electrons. In this case, there's one less electron shell. And so the nucleus now only has to pull in 10 electrons versus 11 over here. So here we have 11 electrons. Here we have 10 electrons. So the size of the Na plus ion is always going to be smaller. So positively charged ions are smaller than the original parent atom. Now, when you have the case where you have a nonmetal, nonmetals gain electrons instead, and then they become larger ions, negatively charged ions called anions. These anions are always going to be bigger or larger in size. And so here, what atom do we have here? Well, it has 17 protons, 17 electrons. This is the Cl atom. And it's going to gain an electron, and it will form a Cl minus anion. This has, the original atom had 17 electrons. The ion has 18 electrons. Well, the nucleus with its protons, the 17 protons, can't pull in 18 electrons as well. So the size of the anion is always going to be bigger or larger than the original parent atom. So take a look at your periodic trends worksheet. We'll take a look at these first items. Number 12, which has a larger radius. So we have here an atom and its cation. Remember, positive ions have lost electrons and are always smaller than their original parent atoms. So SR atom is going to be the larger size. Radius refers to the size. Number 13 says which has the larger radius. Here we have an atom and its anion. Anions have gained electrons, are negatively charged, and will always be larger than the original parent atom. Therefore, Br minus will be larger. So now we can talk about something called the nuclear charge. So the nuclear charge is the positive charge of the nucleus, and that's just given by the protons in the nucleus. So for example, if helium has 2 protons in its nucleus, the nuclear charge is just +2. Second example, vanadium has 23 protons, so its nuclear charge is +23. We talk about the nucleus because we want to talk about the attractive force between the nucleus and the valence electrons. And we have a special law in physics and chemistry that describes how things attract. Here, Coulomb's law of electrostatics says that opposite charges attract. And you've heard this before, that positive charges are attracted to negative charges. So here the nucleus attracts the negatively charged electrons. And the attractive force depends on 2 things. The first thing is higher nuclear charge. This creates more attractive force on the electrons. So if you have a nucleus that is plus 10 versus a nucleus that is plus 7, guess what? The plus 10 nucleus can pull in electrons better than a plus 7 nucleus. The second thing is that closer the distance, between the electrons and the nucleus, is going to cause more attractive force. So the closer these electrons are to the nucleus, the more attractive force they will feel. And then you have a plus 10 nucleus, we'll just keep it the same, and you have electrons in this first shell, but then you have another shell of electrons, and you have some electrons in this second shell. The ones outside here on this outermost shell will not be as attracted to the nucleus because it's farther away. This electron is not going to feel as much attractive force as the electron close to the nucleus. So here, periodic trends worksheet number 14. So let's take a look. Which has the larger radius, Na plus or Ne, which is neon atom? So here, if we take a look here, we have 11 protons. So we have a plus 11 nucleus pulling in how many electrons? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So pulling in 10 electrons. For neon, we have a plus 10 nucleus pulling in also 10 electrons. Which nucleus is not going to be able to pull in those electrons as well? That would be the neon nucleus. It's only plus 10 versus plus 11 for the sodium. So if it cannot pull in 10 electrons as well, these electrons will spread apart a little bit more, and this neon atom will be larger in size, will have the larger radius. All right, so then here's periodic trends worksheet number 15. Give it a try. Look at the nucleus, the charge on the nucleus, and count how many electrons it's trying to pull in. Look at the charge of the nucleus here and count how many electrons it's pulling in. First of all, 20 protons. This is our Ca2 plus ion. Over here, 17 protons means this is the Cl minus ion. Try to figure out which one's going to pull in those electrons more or less based on the nuclear charge and the number of electrons you have, and then explain that answer in number 15. Why does the atomic radius of atoms get larger as you go down a group in the periodic table? And so we'll look at this with two atoms, the noble gases, neon and argon, and these two atoms we're going down a group. It goes helium, neon, argon, krypton. And so you can see that argon's right below neon on the periodic table. So if you take a look here, neon has two electron shells. Argon here has 1, 2, 3 electron shells, has more electrons. So we need 3 electron shells to fill these, to put in the electrons. If we looked back at helium, helium only has 2 electrons. It has 2 protons, and it's surrounded by 2 electrons. It only has 1 electron shell. These electron shells are certain distances from the nucleus. So as we add electrons and add electron shells, the size of the atoms gets larger. So that's why we see this trend of the atomic radius getting larger as we go down a group. So we could explain number 17 here by saying it gets larger, the atomic radius gets larger, because as we go down a group, another shell of electrons is added. This outermost shell is further from the nucleus, which increases the size of the atom. So as we go down, we add shells, okay, each time as we go down each period. And so the outermost shell is going to be further and further from the nucleus as we go down, and this increases the size of the atoms. So I hope this video was helpful, and you should be able to answer all of those questions at the end of your worksheet, and we will discuss these questions more in class tomorrow.